Well, good afternoon, good evening, or even good morning, wherever you are in the world and whatever the state of your COVID restrictions. Now, we've got several hundred people registered to be tuning in today from dozens of countries, and you are all most welcome. In this PETinar, we will be hearing from two companies, Gneuss and Sukano, who will present an overview of their latest developments, their disruptive technologies and novel and innovative additives in the field of real closed-loop PET recycling. Now, we will have time for questions afterwards, and if you look at the bottom right of your screens, you will see a box where you can enter and submit your queries. Now, they will be moderated. I know you want to say hi to your friends, business connections, and colleagues around the world, but I'm afraid that those greetings will not appear. My colleagues will filter them out, so please keep contributions focused on the subject. I will select as many as possible for the presenters to answer within the time available. Now, Gneuss will present its recycling technologies, including its brand new MRSjump extruder, which it says has a disruptive influence on PET recycling. Now, Gneuss recycling processes are designed to clean and decontaminate even heavily contaminated PET waste, allowing film to film, fiber to fiber, and even bottle to bottle recycling. Sukano has developed masterbatch formulations with unique match properties to these, which uniquely match properties to these innovative and yet challenging sources of newly recycled material. Its masterbatches are designed to ensure productivity and processability in the final RPET tray-to-tray parts and help maximize the content of the opaque RPET granulates in next-generation PET opaque bottles. Now, first up will be two speakers from Gneuss Kunststofftechnik GmbH. Founded in 1983 and based in Bad Oeynhausen in Germany, it has over 100 international patents. It's still family-owned and operated, and Gneuss has made a name for itself as a supplier of innovative solutions for the plastics processing industry. It has a daughter company in the USA, offices in Brazil and China, a cooperation partner in Japan, and representatives worldwide. Dr. Axel Hannemann, Head of Fibers and Pellets and Technical Sales Manager, has been with Gneuss for 22 years. He is a graduate in engineering and plastics processing and holds a doctorate in mechanical process engineering. Dr. Karl-Jürgen Wefelmeier, Head of Film and Sheet, studied industrial engineering and also holds a doctorate, in his case, in engineering, which he gained at the Institute for Polymer Processing at the University of Paderborn. He has worked in the field of He has worked in the field of sheet extrusion for more than 20 years. He joined Gneuss 11 years ago, and he's head of the business unit of film and sheet at Gneuss. Following Gneuss, we have a complimentary presentation by Alessandro Funcia, the Global Head of Marketing and Head of Sales EMEA at Sukano AG. Now, Sukano is a Swiss company, and it's a world leader in the development and production of additive and color master batches and compounds for polyester and specialty resins. With a background in chemistry, Alessandra is responsible for the planning, development, and implementation of marketing strategies and communication activities with a particular focus on polyester resins, recyclability, and bioplastics. Her responsibilities are in the leadership, management, and development of sales and the sales team in her area. I hope you're looking forward to these presentations as much as I am. So now over to you, Dr. Hannemann and Dr. Wefelmeier.
Yeah, thank you, Rari, for these welcoming words. And we also like to welcome all of you to our presentation, which we will do now from over here. I just do have some slides prepared over here. That's the overview, which you can see over here. So we do have two speeches. One is held from Karl over here, who's talking about post-consumer tray recycling, and I will follow up with post-consumer PET and bottle and fiber production. And later on, Alessandro will give you a short lecture about additives which are developed for the PET recycling. As Karl and I are staying over here in Bad Oeynhausen in Germany, it's up to me to introduce you first of all very shortly to the company Gneuss as an introduction to that. And then I will hand over to Karl, and then he will start his presentation, and later on I will come back again then. Okay, so I'd like to give you some information about our company before, and in order to do so, we will make ourselves a little smaller that you are able to see the complete presentation on your screen over there. As Rory already mentioned, company Gneuss was founded in 1983, so almost 40 years ago. Mr. Gneuss was developing a very special screen-changing device, which allows you to go really in process constant filtration for recycling and stuff like that. And since that, Gneuss Kunststofftechnik was developed very well and expanded several times. You can see that on the slide over here. So we had something like 4 expansions so far. Latest one was in 2018, and we are located in Bad Oeynhausen, somewhere in the center of Germany. In the meantime, we do have 200 worldwide employees, and we're also working all around the world with several distributors and agencies. We do have a subsidiary in Massachusetts, North Carolina, in the US. We do have another daughter company then in Brazil and in China. And yeah, you see that's almost something like 40 years of experience in the field of recycling. And yeah, we do have more or less four business areas. The first one is regarding the filtration technology, which you see here on the bottom right, which is the oldest one. Here we developed the rotary screen changes. Then we do have the measurement technology on the bottom left, which is developing the latest melt pressure and melt temperature sensors. Then we do have something like 15 years ago started the extrusion technology, and last but not least, we put that all together, and then we do have turnkey solutions. You're all welcome to have a look in our facilities over here, send over some materials, and then we will do a trial over here in our laboratory. So we do have several extruders over here. We will have another sheet line over here. We do have a palletizing line over here. And for sure, we do have all the equipment which we are selling over here that we are able then to get really in detail with your material, with your recycled materials, which are all different because well, recycling all around the world is different due to the fact that it's collected and sorted and washed differently in all parts of the world. So this was a few words to the company Gneuss, and now I will hand over to Karl, who will give you some more detailed information about tray recycling and what we can do with bottle flakes and sheet and how PET can be recycled. Enjoy.
Thank you very much, Axel. Yeah, also a warm welcome from my side. And I will give you some information about the Gneuss PET recycling lines, and especially about the Gneuss post-consumer tray recycling concept. I will begin with the bottle-to-tray recycling with our standard MRS extrusion process. But not only the extrusion is important, also the filtration for the recycling. And due to this, I will present the RSF Genius rotary filtration system. Furthermore, we are able to monitor the viscosity inline with our online viscometer, so-called VIS. And last but not least, you will get information about the unique tray-to-tray recycling concept called MRSjump extrusion. But start with the bottle-to-tray recycling with a multi-rotation system. And it's not only the extruder, it's a so-called Gneuss processing unit. And this Gneuss processing unit consists of an extruder, a filtration system, an online viscometer, and a vacuum system for the extruder. This system can be integrated in several applications, like a sheet line application. And here you see a turnkey standard sheet extrusion line for a bottle to sheet or a bottle to tray process. So you see this system is starting with the dosing system and ending with the winding system of the sheet downstream. And in the middle, there is a Gneuss processing unit. So how does the MRS extruder work? And here we have a comparison between the MRS extruder and the conventional single screw extruder. And it's very obvious that the MRS extruder is working without any pre-treatment. So there is no pre-drying, no crystallization step prior extrusion. And due to this, there is a flexibility which is much better compared to conventional systems. We save a lot of space and a lot of energy. So we can go to the next slide. So, but the question is how I can get from an RPET material, from a post-consumer recycled material, to a food-grade tray. And here you see the processing steps. So in the MRS extruder, we melt the material without any pre-drying. And the next step, this is a unique step, this is a so-called multi-rotation step. And this is a special degassing and decontamination section with a vacuum attached. And this section has the highest cleaning efficiency. And this leads to a food-grade EFSA or FDA-approved product. But the downstream filtration step is also really important because we can filter mechanical impurities. And finally, we are experts in cleaning of melt. And with this cleaned and decontaminated melt, we can make a sheet from that. And from that sheet, we can make a tray with a thermoforming step. So, but what is so unique? So when you look at the MRS extruder, the design is unique. So it's a single screw technology, but with a special multi-rotation section. So it's a multiple screw section, which you can see in the picture above. As I said before, this leads to a dryerless extrusion, and this multiple screw section gives efficient and perfect distributive mixing under vacuum. The system is especially developed for the recycling applications and therefore also suitable for the polyester recycling. We have a very efficient degassing and decontamination. But how does it work? How does this extruder look like? And here you see the animation. So the extruder looks more or less like a normal single screw extruder. And when we look inside the machine, then we see the screw. And when we stop here, we see the elements, yeah? The feeding section, so it's a system with a multi-rotation section in the middle. But in general, it's a single screw technology. So there is a feeding section and a multi-rotation section in the middle and a discharge section. And when we start a little bit again, the animation and stop here, so we see very well the multi-rotation section. This section is a bigger screw. We call it rotor. And inside the rotor, there are integrated several satellite screws. These satellite screws are designed like venting screws. So it's a combination of several venting extruder in one machine. And the trick is that these venting extruders or satellite screws continuously exchange material from one satellite screw to the other one. And so you can imagine when there is attached a vacuum, you create a big surface and a continuous surface exchange under vacuum, that this is a perfect degassing and decontamination and homogenization under vacuum. When we continue this film or this video, we see that we have also a discharge section, which is really important to build up the pressure. But let's take a look at the system with material. So due to the fact that this system is working like a single screw, is a flood fading system, and the material and our material mix comes from the full hopper. It can be bottle flakes, mix of bottle flakes in sheet regrind from skeletal waste and edge trim. And then we melt the material directly without any pretreatment, and then this material enters the MRS section. We have attached a vacuum here, and you can imagine how good the material is really distributed in this section. And we have this satellite screws, which exchange material from one satellite screw to the other one. This perfectly degassed and decontaminated material enters then the discharge section. And the discharge section is able to create a perfect pressure buildup. So the high pressure buildup for the downstream filtration step. So this is the working principle of the MRS system. And this leads, of course, to advantages, to unique advantages. Yeah. So as I said before, we have a single screw technology. This means the operators knows very well how to operate the system. It's a very simple system. There is no pre-treatment prior extrusion required. So we have an efficient distributive mixing under vacuum, so the melt is very homogeneous. And this is also very important. This is a system in the market which is especially developed for the recycling and especially developed for the polyester recycling. But the system is able to process other materials like polystyrene, PETG, PLA, and PP as well. Of course, we have a... it was a little bit too fast. I'm sorry. Is it possible? Yeah, okay. Thank you. So with this system, you can imagine that the process chain is really very short. And due to the short process chain, we have low thermal stress on the material. And this is very good for the mechanical, but also for the optical properties. So I said before, we have the food approvals due to the good decontamination. And these are typical approvals, well-known approvals like the FDA or the EFSA approval. But we have got other approvals, local approvals, for example, from South America, which is the Anvisa approval, INVIMA or SENASA approval. This is valid for up to 100% post-consumer recycling input material. But not only the extrusion step is important, also a downstream downstream filtration step. This is a good combination. The MRS and the rotary filtration system is a perfect fit, which works very well together. And the rotary filtration system is a unique system. So what does it feature? So this system is working process and pressure constant. It is working with an integrated back flushing system, so you can reuse the screens very often. It has an encapsulated design. This means the polymer doesn't have contact to the ambient air, and we avoid oxidation. And this is really important for the PET. It's working fully automatically, and you see in the picture above, it has a constant active screen area, which is shown in red there. But now we go to the general design. So the principle is very easy or very simple. This is an infeed block and an outlet block, and in between the two blocks there is a disc which is turning depending on the differential pressure. And inside the disc there are cavities. And inside the cavities, we have the filter elements. And we are always working with the same active screen area, which is really very important for the filtration step. So the animation shows us how this system works. So the dirty material enters the filtration system. And now you see the disc with the cavities and the dirty filter elements. You also see the active screen area, which is really big and always constant. So the system is working fully automatically, and depending on the differential pressure, the disc is rotating. On the back, you see the highly efficient back flushing system, which is working like a syringe. And this system is injecting the melt, the clean melt, which is coming downstream from the filter system. So it's injecting the clean melt by a slit or into a very small surface. And due to this, we can control the back flushing very well. And we only need a very less amount of back flushing material. So this is very well controlled. And due to this, we backflush the screens very well. And we collect the backflushing waste in a trolley below the filtration system. And then clean screens re-enter the process. And this means that we can reuse the screens very often. But at a certain point, when the screens are worn out mechanically due to backflushing, for example, and due to usage, we have to exchange the filter elements. And we can do that very, very easily during production without any interruption of production, because we can open and close the hatch door and exchange the filter elements. So this system is working fully automatically, process constant, and pressure constant. So due to the perfect adjustment of the backflushing parameters, we are able to save a lot of money and a lot of backflushing waste. So compared to a conventional virgin filter, the self-cleaning and the backflushing waste of a RSF Genius filtration system is 5 times less. And this is a lot of material which you are safe. You can use that for your sheet. It's better than throwing it away. Yeah. So, yeah, this is the filtration system. And the next slide is about the viscometer. Everybody is talking about the viscosity, and everybody knows that the viscosity is really very important for the quality of the sheet and, of course, of the final product. And we use an inline viscometer in a bypass. It's a closed loop. And we use a little bit material from the main flow, which is conveyed by a gear pump into a slit capillary. It's a defined measuring capillary. And we measure the differential pressure in the capillary and the temperature as well. And due to this, we can calculate the dynamic viscosity during the process. So we are able to monitor the viscosity and to control the viscosity all the time by means of the viscometer. Up to now, we have discussed about the MRS. And now we are thinking about the tray-to-tray recycling. Yeah. And the tray-to-tray recycling, and for the tray-to-tray recycling, we need a different concept. So when we see the MRS extruder, so we run the system with a vacuum of 25 millibar absolute. And the question is, what can we do to improve this process so that we can increase the input IV or keep the input IV? And this is required for the tray-to-tray recycling. So when you see the Fick's law here, we have 3 factors. So it's this law of diffusion, and we have 3 factors we can influence. It is the residence time, delta T, the surface exchange, F, and the vacuum level, DC. So we reduce the pressure or improve the vacuum. We extend the residence time and extend the melt surface exchange rate. And then we get the MRSjump. So this is using a vacuum with an absolute pressure of 1 millibar. When we compare both systems, on the next slide, these systems both look like extruders. So the MRS is a little bit shorter and smaller, but the MRSjump is still an extruder which can be integrated in a flexible system. Yeah. So in the sheet extrusion, you need a flexible system. And so the MRSjump is a combination of an extruder and a reactor, but it is as flexible as an extruder. And this is unique because a reactor is very slow and cannot be used so efficiently in a sheet line, for example. So due to this, the MRSjump can be used in a closed loop tray-to-tray recycling. So, and we can increase the IV in this MRSjump extruder, which is not possible in the MRS extruder. So Axel Hannemann will later on explain a little bit about the IV levels of the MRS and the MRSjump extruder and other systems. But this is really very unique and also very flexible in the closed loop tray-to-tray recycling. And now I'm at the end of my presentation, and I hand over to my colleague, Axel Hannemann. Thank you very much, Axel.
Thank you, Carl. And I will pick up again, and I'd like to introduce you then a little closer to usage of PET in different applications. I'd like to speak a little bit about bottle-to-bottle recycling, and most of the presentation I will give you some more information about the fiber production. Before I will go into detail about recycling solutions, I will also then explain you about our third IV enhancing device, which if I like to talk about that, and this is what we call the jump fully condensation, and then I will give you some examples about fiber recycling, textile recycling, and bottle-to-bottle recycling. Okay, I think you may remember this slide which Carl some minutes ago presented to you. You can see on the right top side over there the fix your law again. So, and Carl mentioned by using the MRSjump, we are able then to increase the residence time inside under vacuum. So the residence time should be longer. The exchange of surface area, the F, should be longer, and the vacuum should be a little deeper, well, or the absolute pressure should be deeper, the vacuum should be higher, whatever it is. So, and you see the MRS normally is used as a vacuum level of 25 millibars, and we did something special. So we took out, we used the MRS system as it is, as a kind of preliminary cleaning device and lifting device to take out all these other things like waters, like toxics, like oils, whatever is in there. And now we do have the jump system, which you can see on the right-hand side over there. So this is more or less the big brother of the multi-rotating part inside of the MRS, which is just a big vessel with some rotating facilities in there. And this is then under 1 millibar of vacuum that's staying in there, let's say something like half an hour, 40 minutes under temperature, under heat and vacuum. In comparison to the MRS system, for instance, where it's just staying we're talking about at least minutes over there, and the jump system then is having a much longer residence time. So how is it working? Just a few words about the MRS, the jump system itself. It's a liquid heated double jacketed vessel, and inside of the vessel there are some agitating things, and they are just creating new surface areas. So we are getting in with the melt into the vessel, and we are getting out melt of the vessel. So that means there is no need for making pellets in between, and we are sucking vacuum on the top side of this vessel as well. So, and under heat and under vacuum and under a long residence time, something like 30-40 minutes, we are able then to increase the IV, or to take out toxics or other glycols or whatever is in there, which is volatile, and this can be taken out. Normally, this is done by so-called solid state polycondensation. This is what we are using over here is the same system, the same theory of the system. So we are also talking about the diffusion law, but due to the fact that we are talking about liquids over here, the diffusion is much faster. So it's not only liquids, it's generating of new surface areas and a long time under vacuum. So this is really then a very fast increase of the IV. You can see that over there. The time we normally need is something like half an hour, and in order to do the same in a standardized SSP, whether it's nitrogen or vacuum or whatever SSP is used, you need something like 10 hours or even longer for that. So we do have a nice device over here developed, which has a very fast IV increase in the melt phase. So this is very important. The diffusion coefficient is much higher. So that's the reason why this can be done very fast. And if this can be very fast, that also means that the dimensions of the whole system is very small, so you can place it just directly in an extrusion hole, and there's something like 10 meters or 12 meters high like a normal SSP. So it's a very compact design due to the fact that the residence time inside of this vessel is very short. That means we do have a minimum space requirement, and due to the fact that we do need to cool down the melt in order to make chips and put it in an SSP, it's also very low energy consuming later on. And for sure, it is kind of easy to operate and maintain. Everything can be controlled from outside for sure, and it can be used first of all in a pelletizing system. So this device really allows it to run 24/7 without any variation in throughput and process conditions. That is the reason why Carl, for instance, mentioned in earlier days that it's maybe not that easy to operate that in front of a sheet line. And now what we did so far is we introduced 3 different extruders or IV increasing or PET processing units to you, and we like to show you them in this slide over here. So what you can see on the right hand side, this is the IV input material. So you can see that we do have several sections over there for fiber. Well, if you are using fiber waste, for instance, as an input material, then we are talking about an IV of an input IV of 0.64. Bottle to bottle, a bottle input material, bottle flake input material is something like 0.8. On the other hand side, on the left hand side, you can see the output IV. So if you want to produce a fiber, you need 0.64 IV. If you want to produce, sorry, a sheet, you may need something in the low 0.7s, and for bottles, you need something of IV of 0.8. So the first thing I put in here is the MRS system itself. This was the one Carl explained in the very first beginning with the 25 millibar system, the very short extruder with a very short residence time of the melt under acceptable vacuums. What you can see over here, just think about, we are using bottle flakes as an input material. So we were starting on the right hand side with bottles with 0.8, and then we have to go up where the MRS is listed over here, and then you go to the left hand side and you can see, oh yes, I can do sheet out of it and I can do fiber out of it, but there's no way to do bottles out of that directly. And if you also see you want to put sheet material, sheet waste material into it with an IV of 0.7, you're also not able to go directly back into tray. That's what Carl also explained a little earlier. So there is a decrease in the IV by using the MRS, the normal MRS system. So far, this was all okay because bottle flakes have been available, have been quite cheap. The quality was okay. So that was the reason why the MRS system was developed and where it's proved now for 100 times all around the world. Then we developed the MRSjump system, and there you can see the big difference over there. So if you're able then if you want to use now fiber material as an input, you are also able to put to create fibers later on that. Or if you put in tray material, you're also able then to produce trays out of that. In the low IV area, let's say talking from 0.65 to 0.75, the input material is at least the output material has at least more the same IV compared to the input material. So there's a little gap over there with a bottle-to-bottle recycling, but this is something that can also be handled over there. But this is just to explain you how the MRSjump system can be used for tray-to-tray recycling and fiber-to-fiber recycling, which I will come a little later on. And last but not least, we do have the MRS plus the jump system. So this is the normal MRS, a short MRS, together with Russell. And due to the fact that we are able to adjust the residence time inside of the jump system for half an hour, 40 minutes, whatever, we are really flexible to increase the IV to a level whatever is needed. So let's talk a little bit about fiber production. As I told you beforehand, well, we are able to use bottle flakes and do some fibers out of that. So this is all well-proven processes which you can see over there. So we started with bottle to staple fiber. We also have extruders sold with the MRS where we are able to run bottle flakes into non-wovens, even into BCF, so carpet yarn. And the latest development is also going directly from bottle flakes really into the POY or DTY fibers. So this is without any pelletizing step in between. This is really something which we can do. The input material of bottle flakes, let's say 0.78 to 0.8, and the fiber needed there is 0.62 to 0.7. So this is something which is state of the art still, but we see some trouble in the horizon, and this is due to the fact that the bottlers are requested from the government to use more and more bottle flakes in order to produce new bottles. So in Europe, for instance, it is 25% as a minimum till 2025, which is in a very short time, and 30% till 2030. So that means that the bottlers, means the people who are producing the bottles, do have a need to reuse their old bottles, which was not the fact in the last 10 years. Maybe a lot of people wanted to do that, but they say, okay, it's another market and we don't need that, and virgin material is cheaper. But right now this will change, as there is a need that people have to recycle bottle flakes into bottle flakes. That means that the bottlers will take care about their own produced bottles. So that's what we see, at least over here in Germany. There are a lot of big supermarkets which are just collecting their own bottles. So it's an internal loop. So the one who's producing the bottles, selling the bottles, getting back the bottles, and reuse the bottles as well. So that means that the big amount of the nowadays available bottle flakes will not be available any longer, and the leftovers will have a poorer quality, and for sure, due to the fact that the demand is high, it will be expensive. So, and as a consequence, there is a need for different input materials. Like Carlos pointed it out beforehand, the tray producers are looking forward to use their trays again in order to really close the recycling loop. So, and there's another big market. This is the fiber market. So you can see here on the right-hand side lots of fiber waste which are produced normally in an industrial production. So there's roughly 1% of material is waste and can be reused. So that's really a lot of money which is wasted. But can this be used in order to replace virgin material? And the answer is yes, it can be used. The fiber waste has to be sorry, this was too fast. The fiber waste has a low value as it is collected over there. You can see that this was when we started over there. So the people in the industry of the fiber industry have to learn that this material is raw material for their product, and if they handle it differently, it can be recycled. So we did that several times. One solution is what I present to you right now over here. This is called glycolysis process. So the fiber waste will be cutted and agglomerated first, and then it is getting into the MRS extruder over there, and it is operated with a 25 millibar vacuum, so the normal watering standard solution we do have, and then we are adding glycol into the extruder. And what is happening is then that the glycolysis is happening, and so what is going on is that the PET with an IV 0.64 or whatever is reduced or degraded down to an IV of 0.3. That means it's really low viscous, and as it is that low viscous, we are able then to have a very, very fine filtration, taking out all the different impurities in there. And then this low IV melt is get into a polycondensation unit, which normally the big fiber producers do have, and then it's going directly back into spinning. I'd like to show you one example how we did that over there. This is a drawing over there. On the bottom right, you can see the MRS extruder where we do feed in agglomerated fiber waste with different waste, startup lumps, everything in a mixture. And this is then get into the MRS system, and in the very first feed section, it is all plastified and molten. And then we are sucking the vacuum, and with the vacuum, we are sucking out the spin finish oils and the water stuff and all these things which are then not for a good recycling. And then directly afterwards, we are injecting glycol into the extruder, and this is mixed by the extruder as well. And this low IV system and then pumped through a filtration system, an RSF Genius, which can be then really kind of fine filter. It's a small filter which is 20 microns fine. So this is what really can be done. And the tricky thing in that system is that we are doing an online viscosity measurement, like Carl mentioned beforehand. We are measuring the viscosity over there, and the value we are getting over there is controlling the amount of the glycol injection. That means if the IV is a little too high, we are injecting a little bit more glycol, and if it's too low, we are decreasing the amount of glycol. And as a result, we will have a flow of an IV of 0.4 in this example over here, and this is then injected into the main melt pipe of a polycondensation process before everything is going into the finisher. So the main melt pipe also has an IV of 0.4, so there's a static mixer integrated over there, and then it's all going into a finisher, and there the glycol will be removed, and in the very end it's going to the spinning beam with an IV of 0.64. In reality, it's looking like that. In the very back, you can see the hopper where we do the feed of the agglomerates, the agglomerate fibers. Then we do have the MRS section over there. You can see the vacuum system on the left-hand side a little bit, and you can also see in the very end of the extruder an injection dome where we are doing the injection of the glycol. Then we do the filtration, and then the viscosity measurement. And on the very left-hand side of this picture, you can see a pipe which is going from the bottom to the top, and from there it's going directly into the polycondensation vessel. I have to increase a little the speed over here, because lots of people, if you have a look over here in this picture again, they do not like to have the recycled material in their finisher, as they think there's a lot of whatever in there which needs them to open the finisher much more often than what they do right now. And for these people, we do have another solution, and that's the reason why I presented the jump to you. So we'll do have exactly the same, but without the glycol injection right now. So we are using the fiber waste, sucking the vacuum, sucking out all the spin finish oils and that, and then we go for the fine filtration, and then we will put everything into the jump system, which is increasing then the melt to an IV of 0.64. A picture is looking like that. So we do have the MRS system, the vacuum, the jump system, and afterwards we do a pelletizer. And this pelletizer then is creating some nice pellets which can be mixed or blended into the extrusion spinning, which is somewhere around. We installed this installation then in China some 1.5 years ago by a really big company who is producing lots of textiles, lots of fibers over there, and we have been able really to reduce their recycled material, to increase the amount of recycled material and reducing the amount of waste over there. I also told you that we are also thinking about textile recycling, and I have the same question over here, headache or gold mine. If you have a look on the pictures on the right hand side, you will easily see that right now this is so far a headache, and this is mainly due to the fact that we do have lots of different fibers just cutting inside. The production is somewhere maybe in China or in India or in somewhere in the East, and the clothes then are worn here, and in the very end they have to be recycled to lots of shipping. So there's a lot of different stuff in there, and in the very end it's not that easy to do this recycling unless the people, the designers, are asking for mono polymer dresses or whatever. So far it's only the chemical recycling available, which is maybe helpful over there, but so far I have not seen anyone in really production. So it's not that proven. It's very expensive as well. Okay, and I also promised you to give you another short slide, which I do have right now over here. The MRSjump system, for instance, which Carl presented a while ago, can also be used for producing bottle to bottle by just using an extruder without an SSP. So the requirements is an IV of roughly, let's say, 0.8. We do have to have a very low AA content, and we have to have a very low yellow value. So the topics we have to say is that whenever we are extruding PET, there is a creation of acetaldehyde, which needs to be reduced in a later on process, and this can be done in a different step, in a different process step, and therefore we have two different solutions. The first one is to use the normal MRS with an IV of, let's say, 0.7 in the very end, and this has to go then into a normal SSP in order to reduce the acetaldehyde and the increase the IV, or we are able to use the MRSjump, which is then coming out with an IV of 0.78, and the last 2 digits of the IV has to be increased in a different way. And as we have to reduce the acetaldehyde as well, there are some other very low-cost process steps which enables us to deal with a very nice quality for bottles as well. And as I told you beforehand, and Carl also mentioned to you, that we do have all the different approvals for EFSA, for FDA, for all the South American things, also for brand owners, that this system can be used also for bottle-to-bottle recycling. So now we are at the end of our, well, I'm at the end of my presentation. That means also that we are at the end of our presentation. And I will pass now to Alessandra. She will explain us a little bit, a little bit more details about all the different additives Sukano has developed for different kind of recycling. And I will leave you now, and we will leave you now alone for a short time until we are coming back to our questions, to your questions. Goodbye.
Hello. Good afternoon, everybody. I'm assuming that everybody can hear me and you can see me, so I want to wish you all a good afternoon and thank PETplanet for the opportunity and Gneuss for the invitation for this conversation. I will share with you some of our latest innovations about how the use of masterbatch can be combined with the technology that Gneuss presented to you in a way to enable a valuable end of life, a valuable outlet for the recycled PET products to make resource efficient and to contribute to the circular economy and the European goals that we have in front of us, or even exceed the time frame for the European goals. At Sukano, we believe PET is not a problem. PET, on the contrary, is actually part of the solution. And we take this opportunity very to the heart of our business as our purpose of a business to deliver to the society. So if you take a look in the recycling loop, what you see here are the red dots, are phases of the recycling loop where Sukano masterbatches contribute to generate, facilitate, increase the incorporation of recycled content and end of life and different end of life in terms of recyclability. Let's start having a look in the European RPET market with the focus in the collection targets. These slides are used from ICIS. ICIS presented at PETCore 2 weeks ago, and I borrowed these figures from them. There was finally in 2019 an uplift in collection rate in Europe from previous years. And finally, this uplift was actually an organic growth because the consumption level was a little bit lower than the growth of the collection rate. The collection rate was about 5% growing in 2019, while the consumption grew at 4%. There is, of course, you can ask yourself, there is, of course, a great room for improvement in terms of collection, because that's the very starting point for us, the industry, to be able to recycle. But if you look at the right-hand side of the slide, the second very big challenge, or the biggest issue that we face now, is the lack of harmonization in collection systems. And this leads us to a variety of waste quality and waste contamination levels that put us an additional complexity in this field. So if you think of a spread of a collection in Europe that goes from 20% to 99%, and it directly related to whether a country has DRS systems, curbside, blended systems, none of them, all of them, and so on forth. So this has a very direct impact in the quality of the waste that we will be able to use, and this will be part of the criteria on the solutions and the features of the solutions that we offer you. So with more supplies going into market, it allows an increase in capacity. So the nameplate capacity in 2019 achieved 2.4 million tons of PET to be recycled. There was an increase in input capacity of 11% and an increase in output capacity of 9%. But the issue remains the yield. The yield of this process is reducing year on year. In the past, used to be 75%, now is 70%. And why? Again, because of this lack of harmonization and because of the variety of the waste collected in the region. And this implies in the contamination of the waste that we have to work to make it back into the loop. In Europe, if you look to the right-hand side of this slide, you will see that the food contact bottle grade is the main outlet, is a very important outlet for RPET, and as the legislation imposes, it has been also the area that enjoys the biggest growth in recycled PET content use. However, sheet and more specific PET trays have been the major outlet of RPET since ever, and they account for more or less 40%. Because of the new targets, because of the 2025 and 2030 30% recycled content mandate, the sheet manufacturers have to reinvent themselves because they don't find anymore these access to these bottle-grade recycled PET. And that leads me to the next slide, which is a slide that was presented by Ana Fernandez also 2 weeks ago in the PETCOR conference, explaining why PET thermoforms recycling is right now a business opportunity. And I will elaborate further on that. So we see a change in life cycle requirements that demand more packaging. The consumers are demanding not only more packaging, but that this packaging has to be safe and has to present some sustainability features. For that reason, the major brand owners are responding to those demands with the specific packaging pledges. And again, with the SUPD, the higher PCR recycled content demand overall, we have a clear business opportunity for the PET thermoforms trays. So let's have a quick look into the PET trays. So 1 million tons of PET sheet is consumed in Europe per year, and just about 15%, or the equivalent of 145 kilotons, is collected. The major collecting country is the UK, according to Recoup, and we find very difficult to find data outside the UK. We don't know if they don't collect, we don't know if they don't track, we don't know if it's mixed, and they don't know where these PET trays end up. But so far, there is a big room of opportunity to collect and recycle PET pots, tubes, and trays in PET. The Eunomia report analyzed and projected that by 2025 and 2030, if the industry can organize ourselves correctly, we will be up to 550 kilotons recycled PET from trays in less than 10 years. And because of this difficulty that the PET trays manufacturers have to continue to perform as the major outlet, we have to reinvent ourselves. And that leads me to the nice project that Sukano was invited by Gneuss to take a very complex waste mixture, PET waste mixture, and turn it back into a tray, thermoformable, thermostable CPET tray, which means a very valuable end application. So it all started with joint efforts from Sukano, Veolia, ILIG, and Gneuss. What we did, we took the yellow bag from the German households, so it means all sorts of PET that are not clear and bottles. So it can be colored bottles, can be colored trays, and can be transparent trays, all mixed together, which means a very variable, a very mixed properties of waste, with variation in color, in weight, in very different levels of contaminations, and the properties of the PET vary from a very broad spectrum. And here is the challenge. We want to recycle this type of waste and bring it back into a very valuable or a valuable end application that can go back in a closed loop to the market. And let me first explain the role of the masterbatch in this process. So if you think about the waste and where we want to go in terms of a thermoformable, thermostable CPET tray, we need a masterbatch that is, we need a PET that is crystalline. To be crystalline, you need to crystallize the PET, because then you give it the very interesting property to have heat resistance of 200 degrees or up to 200 degrees. But there are obstacles to get there. And this bumpy road, when we crystallize the PET to make it heat resistance, we need time. And to speed up the time, to make it industrially possible, then we need a masterbatch, a nucleating type of additivation through a masterbatch route. Also, I mentioned this is a very mixed colored waste. So we decided to go for a cover of this waste using a black color. And finally, some other functionalities are needed to be able that the sheet is extrudable, crystallizable, and then you can further crystallize and thermoform. So let's have a look what it does together with the Gneuss MRS technology that we just learned a few minutes ago. What it happens is you take the waste from Veolia, from this yellow bag, you mix it with a combi batch of Sukano, which contains a color and an additivation package that goes with nucleation and some other functionality. And what you make, you put it together into this MRS extruder that will give a perfect, or let's say that will give the desired homogenization that you need. It will also purify the PCR with this high vacuum technology, and finally, it will help to stabilize and control the melt viscosity. Combining this additivation of Sukano together with the MRS technology, you are able to make extrudable PET sheet, and that can be formed in a CPET process. So you take the rolls and you put into thermoforming film with a hot mode in the conditions of the crystallization to speed up to the maximum condition of the line at about 170, 180 degrees. And you can thermoform using also the additivation that we put in the beginning of the MRS extrusion process. You are able to thermoform a CPET tray, and then you cool it, and then you stabilize it in a tray that looks like this. There were several tests done, there were several mixtures done, but at the end, I'm very happy to share with you what we achieved was an oven test with a stable CPET black tray that resists at 200 degrees for 20 minutes. And that is the proof of the concept that we were looking for to make a tray-to-tray recyclable PET product. So I have the opportunity to present you a little bit of some other very interesting innovations that Sukano brought to market recently, all of them to address RPET. So you can move some portions of multi-layer PET trays to mono PET trays using our impact modifier for cold applications. We discussed the tray-to-tray crystallizer. We also have NIR detectable colors and blacks that allow people to design and be creative in the color space, and is still detectable at the sorting lines. We have white PET bottles that are designed to be up to 100% back into a closed loop recyclable, maintaining light barrier protection in a monolayer application. And we also have different types of technology that allows IV lift, IV enhancers to different sorts of waste quality or incoming waste type. Sukano is Swiss-based, is a family-owned business, and we have 3 sites in Americas, in the US, in Malaysia, in Asia, and in Switzerland, where I am sitting, I'm talking to you right now, as our headquarters. And with that, I hand it over back to the colleagues.
Hi, Alessandra. Thank you very much indeed for that. That was pretty interesting. I've got some questions that I'm going to put to you all now, and we're going to go first with a couple of questions for Gneuss, actually more than a couple. The first one is one that I would like to ask, and as I'm the moderator, I can actually put it to you. I'm in the privileged position. One thing you haven't addressed is the cost implication. One of the hurdles to people using RPET rather than virgin PET has been the cost of processing. Does your equipment have an impact on the cost, or are we going to have to look at other means of encouraging people to be more responsible?
Do you like? Shall I?
Yes, I can.
But you are muted.
Sorry. I can. Yes, I'm now I'm not muted anymore. Yeah. So with this system, so it is not so easy to say yourself euros, yeah, 1,000 euros, 100 euros, whatever. But we can say that we save a lot of energy. We have 350 watt hours per kilogram energy consumption. And what I have shown in my slide, in one slide, that there is a big difference in energy consumption there, yeah, because we skipped the pre-treatment, the crystallization and pre-drying. This is only one thing, but on the other hand, you are able to process low quality material with a lower quality, yeah, and of course you can save a lot of money due to the savings in input material. And concerning the filtration step, this is very easy to calculate when you have only a fifth of the backflushing waste, yeah, compared to conventional purging filters. Then it's very easy to calculate the return on investment calculation. If somebody would like to have a calculation or is interested in that, please contact us.
Okay, that's fine. So yeah, two aspects to it. One is the quality of the raw material that you're reprocessing, and another is the energy impact. And we do know that energy is a major factor when you're talking about reprocessing PET, when you're talking about RPET. And what you were talking about contamination feeds into the first question from the audience, which is from Jocelyn Boda. I hope I pronounced the name correctly. And that is, does the rotary filter also take out more contaminants and therefore leave less or fewer black spots than a conventional filter?
Well, maybe I can answer that if you don't mind.
Please.
Well, due to the design, like Carl was explaining, that we do have an inlet block, an outlet block, and in between this rotating disc. So one of the design criteria was to have no dead edges in there. So there is no degradation in the filter itself. If you compare that to different kind of filters as well, they are all, due to the fact that they are designed in a different way, they all do have some dead zones where the material is able to stay for quite a while, and then you are creating your black specks on on the filter side, and that is what the rotary filter does not do. Beside that, one of the advantages of the rotary filter is that it doesn't make any difference if the filter is operating or not. Means a screen change, if you like to say that, an exchange of screens out of the area is no longer a big topic, because it's all kept constant. So that means the possibility to use finer filters is also given. That also means by using finer filters and having the right rheological design, for sure this filter is also reducing the amount of black specks in the very end.
All right, that's good. That's great. Thank you very much indeed. Now, Wolfgang Steinwender says, what's the possible IV increase with the MRSjump?
Well, maybe also I can get an answer over here, and you will get a very technical answer, which says it really depends. What we have seen, so what we have seen, yeah, right, right. No, what we've seen so far is that we are able to increase the IV with lower IV input materials. So thinking about fiber, textiles, or even tray. Well, let's start with the fibers waste material, or with the fiber material with an IV of 0.64 input, whatever. We are able to get out a slightly increased IV of 0.67 or whatever. Talking about the tray recycling, when we start with 0.65, 66, whatever, up to 67, this will be more or less input will be exactly the output, or output will be exactly the input.
Okay, it'll be the same. Exactly.
It will be the same. And if you're going to the more longer molecules, like if you think about strapping materials with an IV of 1 point something or 0.9, there will be a small decrease as well.
All right. Okay, that's fair enough. Thank you for that. Alessandra, we have one for you, and that is, do you think, it's from Patrick, Dr. Ammerheim, do you think without chemical recycling there will be enough quality recycling material available?
Well, that's more of a opinionating. I'm a chemist as education, so I stick to science. I believe in science. And there will be certainly room for several mechanical recycling improvements, a lot of room for several mechanical recycle adaptation to be able to incorporate other types of waste, like we saw on the tray-to-tray. And ultimately, there will also be chemical recycling. And in PET, we like to say monomer recycling, because we are a polycondensation polymer.
Okay. Now, same gentleman asks, oops, I've hit the wrong button. I do beg your pardon. What about different catalysts or additives that may be present in the material? Will this have an impact on color, mechanical properties, or food grade? Now, that may actually be for both of you.
I guess this is to the PET resin catalyst, right? So I can talk about the additives.
Right, please do.
The additives that Sukano selects to put in the products, they are designed, or they are selected, they are formulated to at least minimize any impact on the recycle stream, the clear recycle stream, and certainly to facilitate multiple cycles, because now we are not only talking about recycling, one use, we are talking about reuse the same material. So there are some other implications in the formulations of a master batch.
Okay. But what about,
and there are some needs of additives to be reformulated, or some new technologies, which I'm very happy we are very happy to welcome in the market, that either do not imply on yellowness or minimize the IV reduction, or so the polymer chain reduction.
Okay. Now, I have little doubt that your additives are as pure as the alpine air, but what about those that are already in the material when it is collected for recycling, which may be a little bit more a question for the gentleman from Gneuss.
Well, and we can also we also have a statement for that. The purer the input material is, the better it is for sure. And what we have seen in the past was, if there is some PA material in there due to beer bottles or whatever, or if there is PVC labels around that, which is a kind of additive for sure, well, this will decrease the quality in the very end, but we have also seen if somebody is using the wrong additive. So we have seen, well, not only the ones from Sukano, we also seen from somebody else. And we have seen that if this is a wrong formulation, it will create also problems later on. So for instance, for acetaldehyde catchers, scavengers, whatever, this is really kind of tricky, and you have to have the right partner developing the right additives for that.
Okay. Well, I must say, from my point of view, or from my perspective, the fact that you're able to recycle black trays to black trays is pretty impressive, because I do try to recycle. Obviously, I'm contributing to that extraordinarily high collection rate that you highlighted in the United Kingdom. But I turn over the black tray and it keeps on saying "not yet recycled, not yet recycled." So, as far as I'm concerned, this is a breakthrough and very welcome. Now, Michael Zborek says, have you any experience with RPET into BOPET, B-O-P-E-T? I think he means BioPET.
No, he means BOPET.
Biaxial oriented PET.
So the from my experience, BOPET is very thin, and due to this, any particle inside the BOPET and any change in material quality leads to problems. So this is a much more sensitive process compared to a thermoforming sheet. Okay. And due to this, we are in contact also with other machine suppliers who manufacture also those machinery. Usually those products are made from a virgin material, or only a little bit RPET, but not the content we know from the thermoforming sheet.
Okay, thank goodness.
Well, maybe I can also.
Okay, sorry.
Okay, maybe I can also give you some example over here. We do have an installation somewhere in the very eastern part of that world where somebody is really using BOPET out of 100% bottle flakes. Sorry, it wasn't 100, it was something like 80% bottle flake, but that doesn't matter. The problem what we have seen over there is that it has to be a really high homogeneity of the input material, first of all. And secondly, you have to filter out really, really small hard particles. So this is something which we can do with our recycling filtration system, like Carl presented it to you, because each of these small particles in there is a possible breaking point during the stretching. And last but not least, it's not only the hard particles, the problem over there is also the soft particles, like gels or whatever. And they will also then destroy the film in the very beginning. So that means you really have to take lots of care about the input material, of the sorting, of the washing, of the all the steps before entering the extruder, and also you have to take care about the filtration very much. And this is then maybe possible. It's not easy, but it is possible.
Okay,
from the filtration point of view, right. So maybe we are talking about extrusion on one hand and the filtration on the other hand.
Exactly.
It almost sounds like the situation we were in with sort of mainstream RPET. Say about five or 6 years ago, that the quality of the input material had to be really an awful lot higher than you're talking about now. Whereas, it's pretty good. Now, Carsten Fritsch asks, does Gneuss also offer a finisher for melt polycondensation?
I think this is, well, what I presented was a jump system over there. And the jump system is a kind of finisher for melt polycondensation, but this was developed specially and so far only for the recycling of PET. So it's just a question of the size to go from a lower HIV to a higher IFA. It's just a question of the of the size and the residence time in there. For sure, it can be done, but I'm pretty sure that there are big engineering companies which are thinking about throughputs of, I don't know, 10 tons an hour, even 20 tons an hour, and our biggest one is doing something like 2 tons an hour. So it's only made for, so far, only made for recycling.
Okay. Now, question for you, Alessandra. How do you control the B value, i.e. how do you keep yellowing under control? Now, you did refer to that, and I didn't catch everything. So if you would cover it again, I'd be grateful, and so would Bharat.
I'm afraid I did not mention the B value, and in a black tray, that would not be the case. But I do understand this question absolutely, and we do have specific additives that are designed to minimize the yellowness of the recycled PET. There is always a limitation because it's kind of creating a optical illusion to the consumers or to the end applications. So we are able, from a color space, if you talk about the color, the color circle, what we do is we bring the shade of the polymer to the center of the circle, trying to make it more neutral. So instead of yellowish, greenish, we try to make it more bluish and grayish instead. So it is the appearance of the bottle, depending on the content or the appearance of the tray, depending on the content, with this kind of additive, will be not equivalent to virgin, but a lot better than without additives. And this additive formulation allows several recycling loops, which is now what we care also. It's not only once. We need to be able to use it.
Okay, that would be good. Gneuss again. What would be the expected working life of rotary filters? And it's Frank Rain who's asking that, or Frank Rana who's asking that.
Okay, I will do that. Okay, so as mentioned before, I'm working now for 22 years in Gneuss, and I'm still know some filters which have not been here in the meantime. So the lifetime of a Gneuss screen changer is endless. And as Carl mentioned, it's two hard blocks out of steel and a rotating disc in between. And even if there is a need for a renewment of the surface areas, this also can be done, and everything can be polished again, put together, and then it's back in use for the next, I don't know, 5 years, 10 years. So they are also used in continuous polymerization plants without a stoppage for, I don't know, 5 years or 10 years.
So indefinite is really the answer. Yeah, we haven't reached the end.
Right.
Okay, that's good. All right, Virza Mohammed says, in PET injection molding to produce PET preforms, there is a process called purging, in which the first material is, in the plunger is shot out before the production starts. Now that material is crystallized. So can that material itself be recycled? And what sort of treatment is needed to make it recyclable?
Wow, I'm not
so
sure.
In my understanding, this is the starting material from the injection molding for the preforms. Yeah. So it's similar to preform regrind, I would say. Yeah. Okay. So from the IV point of view, I don't see a restriction there because it's more or less the same material. And so this is when it's regrind, you can process it directly without any pretreatment.
Exactly. And whether it's crystallized or amorphous, it doesn't make a big difference, at least in our extruder.
Right. Okay. Now, a similar question, I think. Now, more and more coated PET, or PET coated with carbon or silica, is getting into the market. Will the filter remove these, contaminants, really, I suppose they are, in the reprocessing?
Yeah, that's not that easy to answer. Well, in theory, everything can be taken away as long as it's a solid particle. The question is, how big is the particle? So our smallest screen we are using has holes with a diameter of 3 microns. So this is very, very small, but I think the silica is maybe even bigger, even smaller, so it may pass through that. So there's always kind of questions if color can be filtered out or if something else can be filtered out. Well, in theory, yes, everything can be filtered out by using really fine screens, but sometimes it doesn't make any sense to filter that out economical-wise, because the filter has to be huge there.
Right. Okay, that's fair enough. So what would you do then with material that still has contaminants of carbon or silica?
Yeah, the question is there really a need to do that? And
or
this is something.
Is there a use for it, or is there a need for it?
Yeah, well, this is something what the consumer has to decide later on, as well as the designers have to decide for that. I remember the days 10 years ago, whenever the bottle designers wanted to have several layers in there with some funny stickers in there with a different material. And in the very end, they said, no, we can't use that any longer because there's no way to do recycling that. So, and this is something I think for the future that all the people, means the consumers, as well as the designers, also have to think about, is there really a sense putting a coating, carbon coating or silica coating above that?
Yeah. Okay. Yes. Sorry, I mispronounced Mr. Rana's first name. I thought it was Frank. I've now got my glasses on, and I can see that it is Patrick. And he's asking, is it possible to incorporate fillers or additives in the MRSjump system?
Yes, of course it is. It is. It depends a little bit. When you this is based on a single screw extruder, so you can put the same additives like for a single screw process. Yeah. So there is usually a batch gravimetric dosing system above the extruder. And then you can put the additives, like color additives or these additives we have used during our trials, as Alessandra mentioned. So we can incorporate these additives very well because of the distributive mixing in the MRS section. But it is an incorporation of additives, or is it a kind of compounding process? And when we talk about compounding, like for a twin screw, this is a different process. Yeah. So, but usually in the PET recycling, we use additives, and these additives can be used very easily.
Okay. All right. I think Ferza's question that I've just put up has actually been answered already when you were talking about dealing with crystallized material. Now, so Mike Neal is asking, how does your process deal with PVC contamination or benzene generation?
This is a question for you, Axel.
Okay, let me try. Well, PVC is, I think we should say, this is the arch enemy for PET.
Yeah.
So PVC and we are processing PET at a temperature of around 280 degrees C. What is happening to PVC is it will just fall apart, and then we do have chloride, and this is really aggressive to the ends of the PET, and it will definitely cut the molecules of the PET down. And this is differently to a hydrolysis or glycolysis. This is not a reversible reaction at all. So whenever you put the PVC in, the PET is done, more or less. But I'm not a chemist. Maybe Alessandra can answer that more in a scientific way.
Alessandra, have you anything?
No, I mean, I cannot comment on the MRS technology itself because I'm not an expert. We have two big experts here, but definitely I agree that PVC is the arch enemy of the PET. Like some other ingredients that we do know that they are also arch enemies of the PET. And that's the nice revolution that our chemical industry is going through right now, be that by demand from society, consumers, or legislations. We need to reinvent ourselves. We need to recycle everything we put in the market, and we need to put things in the market that are recyclable from a technical point of view. And I think today we have been able to show at least a couple of alternatives that were not at the table before. We were not discussing them before. So let's walk before we run.
I think you've just about taken my summary away there, Alessandra. That's excellent. I think that's the point at which we wind up. We have come on by leaps and bounds in the last few years, which is very gratifying, and I think we all appreciate the efforts that you and your companies have put in to improving the recycling process and the recycling technology. And I hope that everybody has found this presentation enjoyable and informative. Informative is even more important than enjoyable, but enjoyable is nice. Thank you, all three of you, for your time today. You've been very generous with it, and look forward to seeing the recording and catching up on bits that I may have missed. So thank you very much indeed.
Thank you. Thank you all.
Thank you.
Thanks a lot.
Thank you all. Goodbye.
Guys. Goodbye. All the best. Bye-bye.
Bye to everybody.